January 1945. Clark Air Base, Philippines. American engineers stand before aircraft number 763-12, a captured Japanese G4M Betty bomber, still intact after years of devastating the Pacific skies. What they discovered in the next few hours would change the course of aerial warfare forever. The Betty, that's what Allied pilots called it. To the Japanese, it was the pride of their naval aviation, the Mitsubishi G4M, a twin-engine bomber capable of striking targets over 3,000 kilometers away, carrying a ton of explosives deep into enemy territory. 4 years earlier, in December 1941, dozens of these aircraft had darkened the skies over this very base, Clark Field, turning it into a graveyard of twisted metal and shattered dreams. American pilots who survived that day spoke of waves of bombers appearing as if from nowhere, untouchable, deadly efficient. But now, in this hangar, the beast lay exposed. The inspection team moved carefully around the fuselage. Every panel removed revealed a disturbing truth. The fuel tanks, those enormous reservoirs that gave the Betty its legendary range, had no self-sealing protection. No armor plating shielded the crew. The wings, sleek and efficient, were actually death traps, waiting for a single tracer round to ignite them. The engineers exchanged glances. How had this aircraft terrorized the Pacific for so long? The answer was written in the Betty's very design philosophy. Japan had sacrificed everything for range and payload, crew survivability, structural protection, damage resilience, all abandoned in pursuit of striking power. The Americans had done the opposite. Their bombers were heavier, slower perhaps, but they brought their crews home. Aircraft 763-12 represented more than a captured enemy bomber. It was a window into the Japanese strategic mind, a physical manifestation of desperation disguised as innovation. Every rivet, every unprotected fuel line told the story of a nation willing to trade lives for tactical advantage. This discovery at Clark Field crystallized what Allied pilots had learned through bitter experience in the skies over Guadalcanal, Rabaul, and the Solomon Islands. The Betty could be beaten. It had always been vulnerable. The question was never about the aircraft's capabilities. It was about understanding its fatal flaws and exploiting them without mercy. What follows is the story of that exploitation. How American pilots evolved from terrified targets to precise executioners. How technology shifted the balance. And how the mighty Betty, once feared across the Pacific, became nothing more than a flying coffin, leading Japan toward an inevitable defeat written in burning aluminum and shattered wings. December 8, 1941. The same Clark Field that would later host the captured Betty now burns under waves of Japanese bombers. American pilots scramble to their P-40 Warhawks, but many never leave the ground. Those who manage to take off find themselves facing an enemy they don't understand. The Bettys fly in tight formations, their gunners coordinated, their approach calculated. American fighters dive in, confident, only to be met with devastating crossfire. Within hours, the myth of American air superiority in the Pacific lies shattered across the tarmac. The early months were a massacre dressed as warfare. Lieutenant James Sweat, stationed at Guadalcanal in early 1942, recalled his first encounter with a Betty formation. 7 bombers, flying at 15,000 feet, escorts nowhere to be seen, easy targets, or so he thought. His squadron attacked from above, the standard doctrine. What happened next defied everything they'd been taught. The Bettys didn't break formation. Their gunners created overlapping fields of fire, turning the sky into a web of tracers. 2 American fighters went down in flames within seconds. Sweat pulled away, his Wildcat riddled with holes, his wingman dead. The Bettys continued to their target, dropped their payload, and returned to base. Untouched. This was the reality of 1942. American pilots were brave, their aircraft adequate, but their tactics obsolete. They approached the Betty as they would any bomber, heavy and vulnerable. They were wrong on both counts. The Betty was fast, reaching speeds of 430 kilometers per hour, faster than many early American fighters could sustain in level flight. Its defensive armament, while not overwhelming, was positioned to create kill zones that punished conventional attack patterns. But warfare is the cruelest teacher, and it never stops instructing. After Guadalcanal, after Midway, after watching too many friends spiral into the Pacific in burning wreckage, American pilots began to learn, not from manuals or training schools, but from survival. They started sharing intelligence, comparing notes, studying wreckage. Patterns emerged from the chaos. The Betty's guns had blind spots. The nose, relatively undefended except for a single 20mm cannon. The underbelly, where the bomb bay doors created structural weakness. And most critically, those wings, those beautiful, efficient, utterly unprotected wings filled with fuel. Captain John Mitchell pioneered what would become known as the slash and dash technique. Instead of prolonged engagement, his pilots would dive from altitude, fire a concentrated burst at the wing roots, and break away before the defensive gunners could track them. No lingering, no second passes from the same angle. Hit the fuel, ignite it, move on. The Betty's greatest asset, its range, became its funeral pyre. The results were immediate and brutal. At the Battle of the Bismarck Sea in March 1943, American and Australian pilots put these lessons into devastating practice. A convoy of Japanese transports, escorted by Betty bombers, attempted to reinforce New Guinea. The Allied fighters attacked in coordinated waves, each targeting specific Bettys, focusing fire on wing sections and fuel tanks. Of 16 Betty bombers, 15 burned into the sea. The sky rained fire that day, and with it fell the illusion of the Betty's invincibility. But tactics alone weren't enough. The Americans needed discipline, coordination, the kind that only comes from relentless training. By mid-1943, the training program stateside had evolved. New pilots spent weeks studying Betty recognition, learning to identify its silhouette in fractions of a second. They practiced deflection shooting until their trigger fingers cramped. They flew mock intercepts against bombers modified to mimic Betty flight characteristics. The old cowboy mentality, the lone ace seeking glory, gave way to team tactics. Flights of 4 worked as single units, each pilot assigned a role. Attack vectors predetermined to communication constant. Squadron Commander David McCampbell implemented a rotating system during missions over the Philippines in 1944. His fighters would engage in waves, the first group drawing defensive fire, the second exploiting the gaps created. It was cold, calculated, industrial-scale killing, and it worked. McCampbell's squadron recorded a kill ratio of 7-1 against Betty formations. Not because American pilots had suddenly become superior warriors, but because they had learned to fight smarter, to exploit every weakness, to turn the Betty's design flaws into execution warrants. The psychological impact on Japanese crews was devastating. Betty pilots and gunners began each mission knowing their survival odds were dropping with each passing month. Some formations reported morale collapse, crews requesting transfers to other aircraft types, anything to escape the flying coffin. Japanese after-action reports from late 1943 onward repeatedly mentioned the changed nature of American attacks, the precision, the focus on vulnerable points, the relentless pressure. By 1944, encountering a Betty had become routine for American fighter pilots. Lieutenant Colonel Gregory Boyington, the famous Pappy, described it with chilling simplicity. You see a Betty, you know where to shoot, you shoot there, it burns. Next target. What had once been a terrifying adversary had been reduced to a checklist item, a problem with a known solution. The veterans trained the newcomers with brutal efficiency. No romanticism, no glory stories, just facts. The Betty carries this much fuel. It burns at this temperature. Attack from these angles. Expect return fire from these positions. Disengage at this distance. Survival first, kills second. The American Air Force had transformed from a collection of individual warriors into a precision instrument designed for one purpose: destroying Japanese aircraft, especially the Betty, with maximum efficiency and minimum American casualties. May 1943. A radar station on Guadalcanal picks up a signal, 70 miles out, closing fast. Betty bombers, 18 of them, heading straight for Henderson Field. 2 years earlier, This formation would have achieved complete surprise, their bombs falling before any fighter could intercept. But this isn't 1941 anymore. Within 3 minutes, 30 American fighters are airborne, climbing, positioning themselves between the attackers and their target. The Bettys arrive to find not an unprepared airfield, but a wall of Corsairs and Hellcats at optimal altitude and speed. 14 Bettys burn before reaching their drop zone. The survivors jettison their bombs into the ocean and flee. The age of surprise is over. Radar changed everything. The SCR-270 and its successors gave American forces something the Japanese couldn't match. Time. Time to scramble fighters. Time to gain altitude. Time to choose the engagement on American terms. The Betty's greatest tactical advantage had always been its ability to appear suddenly, strike, and vanish before effective resistance could organize. Radar stripped away that advantage with cold, electromagnetic precision. Every Betty formation now broadcast its approach like a beacon, its distance, heading, and approximate altitude displayed on screens in operations rooms across the Pacific. But knowing their coming and stopping them required more than early warning. It required aircraft capable of turning that information into dead bombers. Enter the F-6F Hellcat. Grumman's engineers had studied every engagement report from the Pacific. They knew what pilots needed: speed to catch the Betty, firepower to destroy it quickly, and most critically, the ability to survive the counterattack. The Hellcat delivered 650 caliber machine guns, each loaded with armor-piercing incendiary rounds specifically designed to ignite fuel tanks. A top speed of 380 miles per hour, fast enough to overtake any Betty. And armor. Self-sealing tanks, redundant systems, everything Japan had sacrificed, America had installed. Lieutenant Alex Vrasiu experienced the Hellcat's capabilities firsthand during the Battle of the Philippine Sea in June 1944. His division intercepted a formation of 9 Bettys attempting to reach the American fleet. He described it later with clinical precision. First Betty, 2-second burst into the port wing route, immediate fire. Second Betty, same technique, exploded. Third Betty tried to break formation, caught it with deflection shot, wing separated. 6 minutes, 6 Bettys down. The Hellcat gave us the speed to position, the firepower to kill instantly, and the protection to survive their return fire. The numbers don't lie. In 1942, it took an average of 400 rounds to down a Betty. By late 1943, with improved tactics and aircraft, that number dropped to 150 rounds. By 1944, with the Hellcat and Corsair in widespread service, some pilots were achieving kills with less than 100 rounds. The Betty wasn't getting tougher. American technology was getting more lethal. Then came the F-4U Corsair, the aircraft Japanese pilots learned to fear most. Chance Vaught's bent-wing fighter combined speed, climb rate, and firepower in a package that dominated the Pacific skies. Its 400-mile-per-hour top speed meant no Betty could escape. Its rate of climb allowed Corsairs to position above bomber formations, then dive through them in slashing attacks that gave Japanese gunners seconds to react. Major Greg Boyington's Black Sheep Squadron flew Corsairs almost exclusively in their devastating attacks against Japanese bomber formations over Rabaul. Their success rate spoke volumes. For every Corsair lost, they claimed 16 Japanese aircraft, most of them Bettys. But technology wasn't just about better fighters. It was about integration, coordination, the transformation of individual aircraft into a networked killing system. Fighter director officers, sitting in radar-equipped command centers, orchestrated aerial battles like chess grandmasters. They vectored fighters to optimal intercept points, stacked them at different altitudes, coordinated attacks to overwhelm Japanese defensive tactics. A Betty formation that once faced random, uncoordinated attacks now encountered waves of fighters attacking in sequence, each wave exploiting gaps created by the previous one. The radio communications revolution amplified this coordination. Pilots could now communicate target priorities in real time, call out damaged Bettys for other fighters to finish, warn each other about defensive fire patterns. What had been individual combats became synchronized operations. Japanese pilots reported that American attacks seemed to anticipate their every defensive maneuver. as if the enemy could read their minds. They weren't reading minds. They were simply talking to each other. Training facilities back in the States incorporated these technologies into increasingly sophisticated programs. New pilots learned to fly with radar vectoring, to interpret controller instructions instantly, to operate as parts of a larger system. They practiced intercepts against target drones until the sequences became instinctive. By the time they reached the Pacific, they weren't rookies learning on the job. They were trained specialists in an industrial-scale aerial killing machine. The Japanese tried to adapt. They experimented with electronic countermeasures, tried varying their approach, altitudes, and patterns, even attempted night operations to avoid radar detection. Nothing worked. American technology evolved faster than Japanese tactics could counter. Airborne radar sets began appearing in night fighters, turning darkness from a shield into another trap. The Betty, designed in the late 1930s with no conception of radar-directed defense, simply had no answer to the technological revolution sweeping through American forces. By late 1944, encountering American fighters had become a death sentence for Betty crews. The technological gap wasn't just about individual aircraft anymore. It was about an entire system: radar, fighters, communications, training, all working in concert to turn the Pacific sky into a killing ground where the Betty could no longer survive. The Japanese High Command knew it. American intelligence intercepts from this period show desperate requests from bomber units for better protection, for fighter escorts, for anything to improve their survival rates. But technology alone doesn't win wars. As American capabilities surged, the Japanese had to make a choice: adapt or die. What they chose, and how it failed, would seal the Betty's fate and Japan's defeat in the Pacific Air War. October 1943. Imperial Japanese Navy Headquarters. Rabaul squadron commanders gather for an emergency conference. The statistics are undeniable. Catastrophic. Betty bomber losses have tripled in 6 months. Entire formations are being annihilated before reaching their targets. Crews are refusing missions. Something must change, or Japan's primary long-range striking capability will cease to exist. The solution, they decided, would be tactical modification. Larger formations became the first answer. If American fighters were exploiting gaps between bombers, eliminate the gaps. Betty squadrons began flying in massive defensive boxes, 18 to 27 aircraft view, each positioned to provide overlapping defensive fire. The theory was sound. More aircraft meant more guns meant deadlier defensive zones. On paper, it worked perfectly. In practice, it accelerated the slaughter. Larger formations meant larger radar signatures. American controllers could spot them from even greater distances, giving fighters more time to climb to optimal attack altitude. And while the defensive firepower increased, so did the target density. American pilots simply adjusted, attacking from multiple angles simultaneously, overwhelming the defenses through sheer volume of assault. At the Battle of the Bismarck Sea, a 27 Betty formation was intercepted by 40 Allied fighters. The coordination was devastating. Fighters attacked in 3-wave sequences, the first from above, the second from the beam, the third from below. The Betty formation's defensive fire, impressive as it was, couldn't track threats from multiple vectors simultaneously. 21 Bettys fell into the sea that day. The Japanese tried altitude variations next. If American fighters were intercepting at medium altitudes, fly higher or lower, Betty formations began operating at 20,000 feet, testing the limits of both aircraft and crew endurance. The Betty wasn't pressurized. Crews suffered in the thin air, oxygen systems strained, engine performance degraded, and American fighters simply followed them up, the Hellcats and Corsairs climbing effortlessly to altitudes where the Betty struggled. Low-altitude approaches failed even more spectacularly. Flying at wave-top level eliminated the early warning advantage of radar, but it also eliminated the Betty's ability to maneuver defensively. American fighters diving from above caught them in a shooting gallery with the ocean as a backstop. No escape, no room to evade, just burning aircraft cartwheeling into the Pacific. By mid-1944, Japanese tactical modifications had exhausted themselves. Every change met an American counter-change. Every innovation encountered a superior response. The problem wasn't tactics, it was the aircraft itself, and Japan lacked the industrial capacity to fix it. The numbers were brutal. Japan's aircraft production peaked at 28,000 aircraft in 1944, impressive until compared to America's 96,000 the same year. More critically, American factories could incorporate modifications rapidly, updating designs, adding armor, improving systems. Japanese factories, bombed relentlessly, strangled by submarine blockades, struggled to maintain basic production levels, let alone implement improvements. Engineering teams proposed modifications to the Betty, add self-sealing fuel tanks, install armor plating, strengthen the wing structure. Every proposal ran into the same wall: weight. The Betty was already operating at maximum design limits. Adding protection meant reducing range or payload, which defeated the aircraft's entire purpose. To truly fix the Betty required designing a new aircraft, and Japan no longer had the resources, the time, or the industrial capacity for such an undertaking. Commander Mitsuo Fuchida, who had led the attack on Pearl Harbor, watched the deterioration with growing despair. In his post-war memoir, he described the Betty situation as a perfect illustration of Japan's strategic bankruptcy. The nation had committed to a weapon system that couldn't evolve, couldn't adapt, couldn't survive the technological and tactical changes of modern warfare, and they couldn't afford to replace it. Material shortages created cascading failures. Aluminum became scarce, forcing the use of inferior substitutes that made aircraft heavier and weaker. Fuel quality degraded, reducing engine reliability. Trained crews, irreplaceable veterans with thousands of hours of experience, died faster than training programs could graduate replacements. By late 1944, some Betty crews had less than 200 hours of total flight time, sent into combat against American pilots, with over 1,000 hours and multiple kills to their credit. The desperation showed in increasingly radical tactical changes. Betty formations began operating almost exclusively at night, accepting reduced accuracy for improved survival. But American night fighters, equipped with airborne radar, turned darkness into another hunting ground. Tactics shifted to dawn and dusk attacks. That brief twilight when visual identification was difficult. American combat air patrols simply extended their hours, maintaining constant coverage. Then came the final, most desperate adaptation, the Oka. The Yokosuka MXY-7 Oka was a rocket-powered flying bomb, piloted by a volunteer who would guide it into an enemy ship in a suicide attack. The Betty would carry it to within range of the target, release it, and return to base. It represented the absolute nadir of Japanese aerial tactics, the transformation of aircraft from weapons into delivery systems for human sacrifices. The Oka missions were catastrophic failures. American fighters learned to recognize Betty aircraft carrying the weapons. They flew slower, lower, more predictably. Fighter squadrons made destroying these Bettys their top priority, knowing that each one eliminated removed not just a bomber, but a suicide weapon and its pilot from the Japanese arsenal. On April 21, 1945, 15 Bettys carrying Oka weapons attempted to attack Allied ships off Okinawa. All 15 were shot down before releasing their payloads. 30 Japanese aviators dead, achieving nothing. This was the endpoint of Japanese tactical evolution, from sophisticated long-range bombing campaigns to suicide delivery platforms. The Betty's trajectory mirrored Japan's descent from aggressive offensive capability to desperate defensive measures. The aircraft that had once terrorized the Pacific had become a symbol of failure, a flying coffin carrying men to pointless deaths. The Americans didn't need to defeat the Betty anymore. They just needed to show up. And the Betty's own vulnerabilities, combined with Japan's inability to modify or replace it, did the rest. By mid-1945, Betty operations had effectively ceased. The few remaining aircraft were grounded, hoarded for a final desperate defense of the home islands that would never come. But there was one more mission, one final role for the Betty to play, and it would be the strangest transformation of all. August 19, 1945. 2 G4M Betty bombers, painted entirely in white with green crosses emblazoned on their fuselages, lift off from Kisarazu Air Base. Inside, no bombs, no torpedoes, no weapons at all. Instead, they carry 16 Japanese diplomats, military officers, and officials. Their destination? Ishima, a small island near Okinawa, now under American control. Their mission? To negotiate the terms of Japan's unconditional surrender. The transformation was complete. The aircraft that had opened the Pacific War with devastating attacks on Clark Field now carried the men who would formally end it. American fighters escort the White Bettys across the Pacific sky. P-38 Lightnings, the same aircraft type that had slaughtered hundreds of Bettys over 4 years of war, now fly as honor guard. Pilots who had spent years learning to kill this aircraft efficiently now ensure its safe passage. The irony was lost on no one, least of all the Japanese crew members who had watched so many of their comrades die in identical aircraft. Lieutenant General Torashiro Kawabe, seated in the cramped, unarmored fuselage, stared through the window at the American fighters. So close. Close enough that he could see the pilots' faces, see the kill markings on their fuselages, each rising sun symbol representing a dead Japanese aircraft, many of them Bettys. The aircraft vibrated with every air current, a reminder of its fragility, its vulnerability. This bomber, this symbol of Japanese offensive power, had become a diplomatic shuttle, protected by the very enemy it was designed to destroy. The Betty landed at Aishima without incident. From there, the delegation would fly to Manila, then Tokyo Bay, where they would board the USS Missouri and sign the documents that would end the war. The Betty's combat career was over. Its final contribution to the Japanese war effort was delivering the men who would surrender. The symbolism was almost too perfect. An aircraft designed with no thought for crew survival, that prioritized range and payload over protection, that reflected Japan's entire military philosophy of offensive spirit over defensive pragmatism, now reduced to a transport plane, its weapons bays empty, its war over. The G4M Betty's legacy is written in fire and failure. At the war's beginning, it represented Japan's reach, its ability to strike deep into enemy territory, to terrorize opponents with unexpected attacks from impossible distances. By the war's end, it represented everything wrong with Japanese military design philosophy. The willingness to sacrifice crew survivability for tactical capability, the inability to adapt when that philosophy met superior technology and tactics, the industrial weakness that prevented meaningful modifications. American pilots who fought against the Betty remembered it with a strange mixture of respect and contempt. Respect for its range and early effectiveness, contempt for how easily it died once they learned its vulnerabilities. One veteran summarized it perfectly. The Betty could fly far and hit hard, but it couldn't survive. And in war, survival matters more than striking power. The White Bettys that flew the surrender delegation were scrapped shortly after the war ended. No museum pieces, no memorial displays, just industrial salvage, melted down for raw materials. The Betty disappeared as it had lived, sacrificed for practical necessity. Its value measured only in what it could provide in the moment, with no thought for legacy or preservation. In the end, the G4M Betty became a lesson in metal and fire about the cost of imbalanced design and the inevitability of tactical evolution. The story of the G4M Betty is more than the chronicle of a single aircraft's rise and fall. It's a study in design philosophy, national strategy, and the brutal mathematics of industrial warfare. Two design philosophies clashed in the Pacific skies. Japan chose offensive capability at any cost, creating an aircraft that could strike deep but couldn't survive the counterattack. America chose balanced design, aircraft that brought their crews home, learning and improving with each mission. The difference decided the war's outcome. Modern military aviation still studies the Betty as a cautionary tale. Air forces worldwide now understand that crew survivability isn't a luxury or an afterthought. It's a strategic necessity. Dead pilots take years to replace. Lost experience never returns. The Betty killed its crews efficiently, and in doing so, killed Japan's ability to maintain aerial warfare. The tactical lessons proved equally valuable. The American evolution from panicked defense to systematic destruction demonstrated that technological superiority means nothing without tactical adaptation. The Japanese failure to modify their aircraft or tactics showed that rigidity in warfare is suicide. The Pacific Air War taught one final brutal lesson. Wars are won not by brilliant opening moves, but by the capacity to adapt, to learn, to improve faster than the enemy. The Betty couldn't evolve. America could. The rest was just a matter of time, fire, and falling aircraft.